tangent and cotangent, okay? Now for this particular one, I am going to leave the pi over 4 because what's the tangent of pi over 4? Who remembers? The ordered pair was the ordered pair was square root 2 over 2. Tangent was what over what? Y over x, or sine over cosine. So that becomes what? 1. Okay? Now this is going to be helpful when it comes to like the A that causes the stretch of these. Those points are going to be helpful. Tangent is sine over cosine, y over x. So if I look at the unit circle and look at 0, which is the ordered pair 1, 0, what's the tangent of that? 0. 0, because it would be 0 over 1, which would be 0. Let's look at pi over 2. This ordered pair was 0, 1. What's the tangent of pi over 2? So again, I have some asymptotes. 3 pi over 4 was the one in the middle with the same set of ordered pairs.
1.
But
-1.
it's negative because the cosine's negative. Pi
0.
is 0. 5 pi over 4.
1.
In the third quadrant, tangent is positive. 3 pi over 2.
Undefined.
Undefined. 7 pi over 4.
-1.
Good. And 2 pi.
0.
Even that has its own little pattern. So at 0, I'm at 0. Pi over 4, I'm at 1. Pi over 2, I am undefined. So I'm basically just going to plot these here. This is what tangent looks like. It curves up close to the asymptote, never crosses or touches. Goes through that point, gets close to the asymptote, never crosses or touches. That's what tangent looks like. Now if I were to continue this, let's get the negatives. Okay? And negative pi over 4, like it repeats a similar pattern, doesn't it? Negative pi over 4 will be a -1, right? Because I got to complete that curve. I'll have an asymptote where?
-pi over 2.
Where else would I have an asymptote? -3 pi over 2. Very good. How? So let's identify that. My asymptotes, right? One of them is at pi over 2. How far apart are my asymptotes? Pi. You guys agree?
Yes, sir.
3 pi over 2 minus pi over 2. Remember, we can always do this. That's 2 pi over 2, which is pi. So I need to write plus n pi. Very good. My zeros. I have a 0 at 0, a 0 at pi, a 0 at 2 pi. Where will my other zeros be if I go to the negative side? Negative pi, -2 pi. So my zeros occur every, how do I represent that?
Pi plus n pi?
I can say pi plus n pi, yep. Or I could say 0 plus n pi.
Or just sine pi.
But it will work. It would. All right. So now that I have my zeros, I can kind of go through and get the rest of my graph because it should follow a similar suit, right? The same type of curvature. At every over 4, I'm either going to have a +1 or a -1. Just depends on what side of the graph you're on, or side of the curve that you're on. And that's the graph of tangent.
So does it have an amplitude either?
So this one does not have an amplitude either. That's correct.
So what happens if there's a number in the front?
If there's a number in front, that just means the graph is stretched, but there is no amplitude. It is that that vertical distance between a middle point and midline and a high point. And there is no high point here. There's no max, there's no min. Hence why there's nothing there. There's no max or min. What's the domain?
Just everything except your asymptotes.
Everything except your asymptotes. So that hasn't changed. That's still the same. Just like the other ones. But what's my range? This one is all real numbers. Remember, this is how we wrote it in set notation. You could have also said negative infinity to infinity. So even though there's asymptotes, that breaks up my domain, that breaks up my x's, but there are no restrictions on my y's. This graph goes all the way down to negative infinity and goes all the way up to positive infinity. No breaks. What's my period? This one is pi. Yep, this one is pi. If you look between the asymptotes, like the graph is the exact same in every little set. So it actually repeats itself on a shorter period, which is just pi. And that is your graph of tangent. Questions? Cotangent is very similar, okay? Except this time cotangent is what over what? X over y. So the cotangent of 0 would be 1 over 0, which is
0.
It's undefined, 1 over 0. Pi over 4 is the one in the middle. Pi over 2.
0.
0. Because it would be 0 over 1, which is just 0. 3 pi over 4.
Negative 1.
Pi.
Undefined.
5 pi over 4.
1.
3 pi over 2.
0.
7 pi over 4.
Negative 1.
2 pi.
Undefined.
So let's get these asymptotes in here. Let's get these points. Looks very similar to tangent, but it's actually like a reflection over your x-axis, and that is cotangent. So this one decreases as you move from left to right, unlike tangent, which increases as you move from left to right. What's the equation for my asymptotes? Give me one of them.
Pi. Or 0.
And then how far apart are they?
Pi.
So then it would be?
And pi.
Very good. So that means I should have an asymptote where on the negative side? What about my zeros? Give me one of them. Where does one of my zeros occur?
Pi over 2.
How far apart are the zeros from each other?
Pi.
So then I represent that as?
And pi.
So that means I should have a 0 where else? On the negative side. Negative pi over 2 and?
Negative 3 pi over 2.
Very good. And so, again, following a similar pattern as the ones before, at every over 4, it should either be a positive one or a negative one. Please make sure they look like some curves, okay? Try to make them as smooth as possible when you draw them. What's my domain? Everything but your asymptote. So the set of x values says that x does not equal n pi. Of course, we know n is an integer. Hasn't changed. What's my amplitude? There is none. What's my period? Very good. And what's my range?
All real numbers.
All real numbers. So very similar to tangent, it just is like shifted over a little bit. When it comes to doing any adjustments with tangent, you remember how we used to do, like we were looking for our period for sine or cosine, it would be 2 pi over b. Now it is just pi over b. Okay? So when it comes to tangent and cotangent, if you're trying to find like the value of, or if you're trying to find your period, the formula is pi over the absolute value of b, not 2 pi, because the period of tangent and cotangent is pi. Same formula, but you got to adjust the period depending on the trig function. Okay? So again, to find the period, you would do pi over the absolute value of b for tangent and cotangent. Let's get these two examples in. This one we're going to do tangent of x over 4. Tangent of x over 4. If you're wondering about the big 5 and everything, that still stays the same. But your y's are clearly going to be different, okay? So the big 5 don't change. Like when it comes to, of course, doing your table. But your y's do change. What was the tangent of 0 again? 0. At pi over 2. Undefined. At pi. At 3 pi over 2. At 2 pi. And remember, tangent is the one that increases. Okay? So you know your graph's going to be going up. What happens to my x's? They multiply by 4 because it would be a 1 over b. B in this case is 1/4 because it could be written like so. So you do 1 over b, so it flips. So 0 stays at 0, but pi over 2 turns into 2 pi. Pi turns into 3 pi over 2 turns into, noticing the pattern?
Yeah.
2 pi turns into, and if I asked you to keep going, the next one after that would be 10 pi. After that, very good. Okay? So, I know in your particular graph, you only have up to 2 pi. So, we're going to actually have just one cycle here. Because the period is, again, pi over the absolute value of b. So that'll be pi over 1/4. So then that becomes 4 pi. Actually, we're only going to have half a cycle. We're just going to have half a cycle on this paper. This is all you guys have, correct?
Yeah.
So at 0, I'm at 0. At pi over 2, I have an asymptote. And since we know that tangent is supposed to be increasing, you only have half of a cycle.
So we're not supposed to find a specific point like in the other one. It was.
We could have done that here. Like if I added in pi over 4, I would multiply that by 4 to get pi. And then that corresponded with 1 on your y value. So technically this point that's at pi is at 1. But I'm not going to be checking for that. I'm going to be more so checking for where your asymptotes are. And then if it's curving up like it's supposed to, unless it's been reflected or something. Identify your asymptotes. 2 pi. How far apart are they?
4 4 pi.
4 pi. So it'll be 2 pi plus
4 n pi.
4 n pi. Very good. And the last one. Cotangent x plus pi over 2. How do the y's go for cotangent?
The opposite, undefined, 0, undefined, 0, undefined.
What's happening to my x's? Subtracting pi over 2. Anything happening to my y's? No. So this becomes a negative pi over 2. The next one becomes
0.
The next one becomes
Pi over 2.
the next one.
Pi.
The last one.
3 pi over 2.
If I asked you to keep going, what would the one after that be?
2 pi.
2 pi. And the technically be a 2 pi and then 0. So, and the reason why I asked that is because your graph does go up to 2 pi, does it not? And I want you to fill the whole graph. The reason why I'm asking you to fill the whole graph is because your homework asked you to fill the whole graph. So, trying to get you in the habit of filling the whole graph. And negative pi over 2, I'm undefined, but that's not on my graph, am I? So it goes to the next one. 0, 0. Pi over 2 asymptote. Pi 0. 3 pi over 2 asymptote. What's happening at 2 pi?
0.
Very good. And cotangent
It goes the other way.
goes the other way, so it decreases from left to right. So this one goes down. This one starts up, then goes down. This one starts up, goes down. So we'll stop there. If you do want to be specific on, like, you know, the pi over 4, none of those, that's where you would be a negative 1. This would be 3 pi over 4. This would be 5 pi over 4, 7 pi over 4, and then you'll have your 1s and your negative 1s. But again, I'm not going to be looking for that. I'm going to be looking to see, do you have the correct period, and do you have the correct curvature? What are my asymptotes? Pi over 2 plus n pi. Do you guys agree?
Yes.
Okay. One asymptote said pi over 2. They are a pi unit away from each other, and that's perfect. And that's how you graph all your other trig functions, okay? Every single one of them has asymptotes. Secant and cosecant are based off of sine and cosine, so do your normal transformations for those and add in your parabolas and your asymptotes. Tangent, cotangent, zeros and undefined. Make sure they're the right way.